Object-oriented programming is a fundamental concept in the world of algorithms, and you will quickly see that using such programming in Python will greatly simplify your work. This is primarily achieved through two essential concepts, functions and classes, and that's what we're going to cover in this chapter. For example, we'll use a function to compute compound interest, where we can easily tweak the parameters, while we'll be using a class to simulate a portfolio management where multiple assets are being bought, sold, modified, etc. You'll see. If you want, there is a written version of this course available on our website. Links below. Now, let's get started. All right, I've opened VS Code and we can create a new Jupyter notebook for this chapter. So chapter 4, I, Pi, Y, and B. Great. And now what can we do? Well, let's create our first function. And this is done using the keyword def. So we start with writing def, which is short for definition. And then we write the name of that function. So compound interest. That will be our first function. Then we have to put parentheses. And then as usual with a structure, we finish that first line with a column. Now if I press enter, I'll be in the function and VS Code has done the indentation for us automatically. And what should we do first? Well, let's just do a little print and say we'll print the word test. Great. Now, if I run this, what do you think is going to come out? Well, let's discover together. Oh, well, you see, nothing, absolutely nothing happened. And that's actually perfectly normal. Here, what we've done is that we've simply defined the function, but then we've never called it. And to call a function, you need simply to put its name below. So like this. So for example, if I run this now, what do we get? Well, we have the test because we've called the function. And what does this function do? Well, this function prints test. That's all. So now we have this test printed because we've called it. And we could call it many times, no problem. So what's going to come out? Well, we will have 4 tests because we've called that function 4 times. And each time that function printed test. Great. Okay, you might be thinking at this point, this function is a bit silly and doesn't have much use, except maybe simplifying a code. That's true. But what becomes very interesting with functions is that you can give them parameters. So in the parenthesis, I have to write a name of a variable. So let me just say text. And now instead of printing test, I'm going to say print that variable text. So now when I'm calling the function, I need to provide an argument to that parameter text, meaning in other words, give it a value. So let's say I want to print hello. So now if I run that cell, we indeed have print hello. So really the cool thing here is that I can choose to give something different. I could say print world. And now if I run, well, I have hello printed. And then from this call, I have now world printed. I could have also put what parameter I'm giving a value to. So I could have written text equal and text equal here. Sometimes it makes things a bit more clearer to do that. So that would just give exactly the same thing. Okay, cool. This was our initial example, but let me now paste a function that does the proper computation of the compound interest. And you can see that this function has now 3 parameters. So the first one, what I call principal, is the initial amount of the investment. The rate then is the interest rate of that investment, while time here is the number of periods over which you want to do the computation. So if we computed something over 5 years, for example, we would put time equal to 5. Then first line, quite naturally, is the mathematical computation of the amount earned given that interest and those amount of periods. So here we apply the formula directly. So amount is equal to the initial amount, so the principal, times 1 plus the interest rate. But then don't forget that the 1 plus the interest rate needs to be taken to the power of the number of periods, so time. Remember that star in Python means to the power of. Okay, second line, what I'm now interested in actually for this computation is to know the amount of interest that we earned. So not the full amount that we'll get at the end of the investment, but simply the interest that we earn. So that's why we say interest is equal to amount minus the principal. Okay, great. Now, last line. You discover for the first time this command called return. And that's really important for function. So you see this function doesn't print anything. It does a computation, and what we want that function to do is to return the result of that computation. So this is why we use this return command here. So we say return what? Well, return what is going to be computed in interest. So this also means that now if I'm using that function, I can do that. I can say A is equal to that function. And here what we will say, well, let's say that we'll start with an initial investment of 1,000 whatever US dollars if you want. Then the interest rate, well, let's say we'll go for a 5%. So I write 0.05. And then let's do the computation for 10 years. Okay, so if I run this, well, we don't see anything happening. We didn't do any prints, but it worked. The function compound interest did the computation of the interest with those values for our parameters, but it simply stored them in this A variable. So if we want to know what is A, what is the value of these interests, well, we have to do print A. Very easy. Okay, great. Let me run it. And we can see that this all amounts to an interest of almost 630. And again, I didn't do that, but if you feel that this makes more sense to you, you could totally put this like that, if that's more clear for you. But just be aware that if you start doing it here, you have to do it for all the variables after that first one where you've put the equal. So here we'll have to put rate is equal to, and then finally here, we have to put time is equal to. Great. So if I run it, we'll get the exact same result. Now from here, we can start making things a bit more involved. Let me paste this little piece of code where I reuse the function. As you can see here, I store the result in this interest variable, and then I print it nicely within the sentence. So a few things that happen here. First of all, you can see that when I call the function, I don't put the values of the parameters directly. I actually define some variables before with the values that I'm interested in, and I then plug in here the name of the variables. This makes it quite handy because now I can just come here and change things, and it's quite obvious, etc. I don't have to come and fiddle in the function. The other thing that you see is that the print here has something new that I haven't introduced yet in this course. You can see here this F. This is what we call basically the F string notation. This is really handy because you see that in the middle of my string, I just came here and put a variable and also some functions. You can put some functions and therefore it will return the value here inside and then it will be printed. In other words, this prevents you from doing what we've seen before, where, for example, you would have to close your comma and put a plus to put your variable, then put another plus, open again the comma, etc. So it does shorten things and also helps make things clearer. Good. The other thing new that you see here is a function that we've never seen before. It's the function called round. So basically the computation of interest will have a certain number of digits after the decimal point. Well, with this round function, I'm simply asking it to round up to 2 digits after the decimal. So let's print the result of this. And you can see that we get 216.65 euros. Here I said euros. Let me just change here now. You'll see that if I put a 3, indeed we get that we have 3 digits after the decimal point. Great. What could be interesting now is to bring in a little loop and use some lists. So we use these concepts that we've just seen recently in the previous chapters. And what we could do is, like, let's say I'm going to create a list. That's going to be a list with several years if you want. So I'll just put 10. Okay, let's do 10, 20, 30. Keep putting a space when I don't want. Anyways, 5, 10, 20, 30 years, 40 years. And the point is to use this function and this little print to see how our compound interest grows with the amount of years. So I've defined this list that I've called LI, whatever, short for list. So now we should do our for loop. So I will say for years, or let's say for Y, make it short, in what? In this list, LI, Now a column as usual. So this, we actually want to keep it in the loop. This has to be in the loop. And actually, I'm just going to take the years here, put it back in here and say that years is going to be equal to what? Well, the thing that is scanning my loop, therefore a Y. So that's it. Okay, so let's run it and see what happens. Great. So we see after 5 years, that's what we had computed before. But now you see that after 10 years, almost $5,000, 20 years, almost $12,000, 30 years, 22, 40 years, $40,000. And remember, this is only the interest, not including the principal. So in other words, you really see with this example, the power of compound interest. After 40 years, you earn almost 4 times your principal amount in interest solely. Anyway, this was but one example, but you see that thanks to this example, we did a already quite intricate code. We have defined a function that does a computation for us. This function takes some physical parameters, physical between quotation marks, some real life tangible parameters. In the context of finance, we're talking initial investment, interest rate, time, etc. Now we want to see the evolution of the interest that we can earn depending on the amount of years we do this investment for. So we're calling this Python object caller list. Great. And then we use a loop to scan through these elements. And each time we use our function and we print the results. So I know I went a bit fast in doing this example. I kind of did that on purpose to stimulate you, but please do take time to understand it at your own rhythm. It'd be really beneficial if you get comfortable with what happens here. Now, what I would like to show you is that you can give some default values to the parameters of your function. So let me put back this example and put it back the way we had done it first. So like this, and like this. Okay. And so to do this, what we're going to do is simply to put time equal to 5. So this means if you don't give time when you call the function, and actually we were going to simply remove the years here, well, the time used in the function is going to be the default value, which you have made it equal to 5. So let's see. If I run this code, what do we get? We get the compound interest after 40 years is our 2,200 euros. And you can see that this corresponds to indeed 5 years. Also, I did that on purpose, but there is a mistake because we have 40 years here, but the default value should be 5. Now what is happening is that now that we gave the default value, we are no longer putting years here. So it is printing the value of years that was declared last. And you can see that we've actually defined it here in the loop. The last number of the loop was 40. So years at the end of this cell, once this cell was run, years is equal to 40. So really, this doesn't make any sense. We should put now, let's simply remove it and this as well. So yeah, the compound interest is 2,000 and we know that it is for our default value of 5 years. But that doesn't mean now that you've given a default value that you can't give one. Of course, you can. We could put 10 years here if we wanted to, and now we'll get indeed the result that we had for 10 years. This is just a way of making your functions more versatile, where in certain uses, you might not want to give a parameter and not bother with that. And sometimes you will want to give it, so you can do this, assigning this default value. And by the way, note that we could have done the way we did it before and add time equals 10. This would give the same value, but be careful. That doesn't mean we're now changing the default to 10. No. The default value is given when you're defining the function. Let me show you. If I now do this again and put it below and now put it back to not giving the time and therefore it will call the default value, you will see that we get back to the result where we use 5 years. So keep that in mind. So now that we've introduced this notation as a means to give a default value to a parameter, I need to talk about some technicalities with the parameters a bit more. So this, in the Python jargon, a parameter defined with an equal like this and a name is called a keyword parameter. While these ones here that don't have an equal are called positional parameters. And there's a good reason for that. That is because here, the order in which you will give the value of these parameters is very important. So let me give you an example. So we'll go back to this, and actually we'll use we'll remove that. And then we'll say here, I'm going to say that my principal investment is, okay, we'll forget that. We'll just go very basic. So 10,000 here, and then I'll put a rate of 0.5. So this is going to give us whatever we've computed. We were going for 0.4. So let me show you. Okay, great. That's equal to that we had here. Very good. But now let's say we made a mistake and we forgot that the order was like that. Then if we do that, then the result that we're going to get is going to be completely different, because Python has no info about the fact that this in our head is actually the rate, while this is the principal. So Python is just applying the rules for a positional argument, meaning first value that comes in goes into here. Therefore, it's used here and here in the computation, while the second parameter is put into here and therefore used in here in the computation. But now with keyword argument, because you define them with a name, Python has the understanding of where it should be used. So their order doesn't matter anymore. Let me give you an example. And let's say we are turning this into a keyword argument and saying that the default value is 0.4. So now I can totally do time is equal to 10 years and rate is equal to 0.02. And this, as you will see, will run and will get, maybe I should put a principal that makes sense. Okay, and if I run it now, you see that we get the good answer. Because now Python here, knowing that these were defined with a name and an equal, it knows that, second argument, what is that? Oh, it's time. Oh, so it refers to time here and refers to time in my function. And the same for rate. Last thing about all of this, you always have to define positional arguments first and then the keywords argument. In other words, if you did this and just put it like that at the beginning, Python is going to complain. And you can already see that VS Code was complaining, because you see you get the error, non-default argument follows default argument. So this is really up to you what you want to define as a keyword, what is as a positional. Again, this will depend on your problem. But what's important, the rule is that you always put the positional arguments first and then the keyword arguments. And you can remember positional means where the order is important. Okay, so we have seen the use of a function and some technical aspects with them, etc. But you might be wondering now, what is actually the purpose of a function? Because we could have just used this everywhere and never defined the function. Well, you must understand that in general, you create a function because what the function does is something that you use several times in your code. So you don't want to have to write this thing again and again throughout your code. So here the illustration would be, well, simply later on, you imagine in your code, you have more computation of the compound interest. So you can simply call it now and just put, okay, we'll just leave those values like this. And you print it now, and you don't have to worry about how to compute the compound interest. You've done it once, it's done here. Your code knows how it is done, and that's it. So you can compute it, use it as many times as you want. You know, you can carry on. I don't know. We do 0.5 here, and then we use it a second time here, and we put a 10, etc. Obviously, this is an example. It's a bit stupid, but think in terms of a general code that now having defined a function really simplifies, because the computation that it does is coded once and for all in a corner of your code, and then you can reuse it as many times as you want. That's really the spirit. All right, guys. I know this might seem overwhelming. Functions are indeed a vast topic, but don't stress. With practice, creating and using functions will become second nature. And now, let's jump into the second big topic of this video, classes. So to define a class in Python, we use the word class. So just like we use the word def to define a function, for classes, it is the word class. So let's define a class called bank account. And you can note here that I am using a pep8 convention where for a class, we generally define its name in the following way. You start a word with a capital letter, and if your name contains several words, this time as compared to functions, we don't separate each word with an underscore. We simply put them together, but any new word will start with a capital letter. Okay, At the end of this name of the class, we don't put any parentheses. We simply put a column, and then we can start defining the main components in that class. The first thing that needs to be defined in a class is its constructor. So this is a method. So a method, if you want, is a function that exists within a class. That is why I'm starting the definition of the method with this def here. And so the constructor is always named with underscore underscore init underscore underscore. I put one too many, so 2 underscores. And then I'll put a parameter name that I call self. So this self here is very important because it represents an instance of the class. In other words, it is through this self that we will be able to access all the variables, attributes, and methods within that class. So this is a bit technical, but you'll get to understand that with some examples soon. So anyways, to finish the definition of this constructor, we finish the definition of a method as usual with a column. Just remember, a method, simply a function within that class. So same conventions. And let's say for this first example in the constructor, I'm just going to say print. Okay, let's do initialization. There we go. Okay. So now let's use that class and create an instance with that class. So in other words, an instance is a representative of that class that will have all the properties that we've defined in here. So let's say account1 is going to be equal to bank account. And here I have to put parentheses because I'm calling them. Note, however, that I don't need to fill in anything for the self. The self doesn't need to be given an argument. In other words, if this constructor was expecting a other parameter, so a, for example, then here I would have to fill in a. But for this first example, we are not putting anything besides this self. So this account1 equal bank account without anything in the parentheses is going to work. So let me simply run this. And you can see that we have indeed initialization that was printed. And note something important here, the fact that we've seen initialization printed here. What does it mean? Well, it means when you define an instance of that class by calling that class, then what happens is that automatically what is executed is what is in this init method. So that's why we call that a constructor. Meaning, as soon as you call the class, what is run is what is in here. Something I should also add on how to read this line is to say that account1 is now defined to be an object of what type? Well, the type bank account. Now, let's add another method to this class. So I will call it, let's say, withdraw. So def withdraw. And again, because this is a method, we always have to start with the first parameter putting our self variable. So I'll finish also by putting one column, and let's say we just do print withdraw for the moment. Okay, so if I actually run this cell, what is going to come out? Nothing changes. That's right, because we haven't called that method yet. If we want to call that method, we have to use the following syntax. So account1 dot withdraw with a parenthesis, and we close it again because we don't call this self parameter. So if I run that cell, now we indeed see withdraw printed. Note, however, that you've already seen this kind of thing where you have a point followed by a method. Remember, for example, when we were doing some lists and we wanted to append a new string, so we had done something like this with our string in there. And so what actually happens here, so I think we did list one or whatever. Anyways, what actually happened here is that we had an instance of a class list, and we were using the method that was defined within the list class, which is called append. So we're doing exactly the same, but this time we're defining the class ourselves. So yeah, for us, account1.withdraw. So actually be careful here. We are allowed to use account1.withdraw because account1 is an object of the type bank account. And in that bank account class, we indeed have a method called withdraw. So say, for example, I removed it or simply commented it. If I now run that cell, what happens? We get an attribute error saying bank account object has no attribute withdraw. Indeed, we had commented it. And also, now you should understand better what I said at the beginning with the representative, the instance being a representative, because you see that now account 1 is a representative, if you want, of bank account, and it has all the properties that are contained in bank account. And for example, one of them was this def withdraw, and that's why we were able to call it at this point here. Okay, moving on. Let's start adding some meaningful parameters to our class. So let's say we'll put a balance parameter in our constructor. And let's say that I want to print this balance. So I'll go balance here. And then when I'm calling the account 1 here and I'm defining it to be an instance of the class, I should give my balance at this point here. So note that the parameters of the constructor, you give them at the moment when you define the object representing that class. So the 10,000 is given at that point here. So, okay, let me run this. And okay, you do see that we get our initialization followed by this 10,000 because we did the print balance here. Great. Now let's say that we want to print the balance after calling the method withdraw. So at that point here. So let's do print balance. And let's run it. You actually see that VS Code is complaining, but let me run it. You will see that we have a name error saying name balance is not defined in the function here. So you might think, well, that's weird because we've defined balance here and we filled it in at that point here. So why is it not recognizing balance? Well, from a logical point of view, balance only, the scope of balance, if you want, is existence of balance is only within the function init. So when we're calling withdraw, well, balance simply doesn't exist. And that's where this self parameter, a bit obscure parameter that we've been writing down so far is so important. Because what we're going to do at this point here is we're going to do self.balance is equal to balance. So we're storing within the class itself a parameter called balance or self.balance that will take the value of balance that we define here. So now, if I run that, oh, again, the same error. That's normal. What we should put here now is this self dot. And if we run that, now we do get the 10,000 printed at this point here. Great. Also, thanks to this little trick, we now are able to access the balance directly within the class. So if we did print account 1.balance, well, oh, I forgot an A, so well, dot balance. If I run the cell, then we indeed print our $10,000 balance. Nice. You should start to see that one of the benefits of using a class is to be able to make accessible variables and methods throughout the whole class using this self parameter. And we'll get to see that even more with the coming examples. But first, let's actually make this bank account and the withdraw a bit more meaningful. So first, let me basically say that we will do an initialization with, and I'll put the balance here so we can print it directly, and I'll put an F string here, and I'll simply remove that there. So if I just comment this and now run it, we should have initialization with a 10,000, and let's say we're dealing with USD. It might make more sense. Okay, so that's done. So I mentioned that we'll make our withdraw a bit more meaningful. So let's actually implement that when we run the withdraw method, we are indeed withdrawing an amount. So here I'm going to add a parameter to that method. So I will call it amount. And now I will do, okay, I will also add an F string so we keep track of things, withdraw of, and then I put amount here. And rather than printing the balance, here we should actually do the computation where we will say that self balance is equal to self balance minus, well, the amount that we're withdrawing. So minus amount. So you see what's happening here is that I'm using this balance that we set when we define our bank account 1 at this point here. But then when I call the withdraw, I can give an amount, and this will update this self balance. So let's actually do that so you see what I'm talking about. Let's say that we're withdrawing $2,000. So let's run it. And what do we see? Well, indeed, when we initialize our bank account here, we set that our balance is of $10,000. Then when to that account 1, we call the method withdraw with an amount of $2,000. We are effectively doing a withdrawal of $2,000. And when we print our account balance after having done that withdrawal, we have indeed $8,000. So I think you see here what I was just mentioning before changing this example, where we have been using this sort of general variable that we've defined. So this is when you define something with self, by the way, is what you call an attribute of the class. I'm not sure I mentioned that before. But so this is now a general variable that exists throughout the class. And you can see that we can use a method to change the value of this attribute. So this is really one of the big advantages of classes. Now, another advantage of defining classes like this is that once you've defined the structure, these methods, you can use them several times. So basically, we could define another bank account. Say we will call it account 2. Say that this account has maybe $5,000. And our first withdrawal that we do is of $1,000. So here I should also change to account 2. And you see, I can run it and the same things apply directly. So you see, it's the same idea as with functions. You define the structure, the methods, what it does once and for all at some point in your code, and then you can use it as many times as you want. I've now pasted here an example a bit more involved of the bank account class. So you see it has 3 methods besides its constructor. And you can see that here in the constructor, I'm also defining a default value for the balance, exactly like we did when we were doing it for functions. So basically, if I call the account like this, if I call bank account like this without putting any number here, then the balance will be automatically set to 0. So then the first method is the deposit method. And you can see that what this deposit method does quite naturally is that it adds the amount that you would feed to that method to our balance. And it also gives a nice little print of what's going on. In the same way, we have the withdraw method, a bit like what we did before, but be careful here. We added a nice little feature where there is a test. And basically, if we try to withdraw an amount that's larger than the balance that we have on our account, then the withdrawal will not happen, but we will get a little print saying that we have an insufficient balance. And well, if this is not the case, we do the withdrawal exactly like we did in the previous example, with also a nice little print to show what's going on. And finally, we have a display balance method, simply to display nicely the balance that we have in an account at any time we want. Okay, so time to play with this a bit. And let me copy this beginning of this example here, and we'll create a new one here like this. I mustn't forget to run this out to compile it. And now we can start with our example. So, okay, we're starting with a bank account with a balance of $10,000. So let's say first that maybe we got our salary. And so we are doing a deposit of, oh, I forgot the one here. So deposit, and we got $1,000. But then maybe, yeah, let's say that we need to eat. And so therefore we go grocery shopping. So I do a withdrawal of, let's say, $200 with a lot of fruit and vegetables because they're healthy, obviously. Okay, so after we've done all that, maybe we'll want to see where we are at, and we'll do a little display balance. So, okay. And remember, we have to put parentheses even if they're empty. And remember here, there's no parameters. The self doesn't count as a parameter to give. So the display balance doesn't ask for any parameters. So that's why I'm giving parentheses, but with nothing inside. Okay, so let's run that and see what happens. Okay, so we've deposited $1,000. So our new balance is $1,100. Makes a lot of sense. But we withdraw then $200. So now we're down to $10,800. Great. And our final balance is $10,800. Cool. Let's say that we went a bit crazy and instead of withdrawing $200, we withdrew $20,000. So you will see that what happens here is that the withdrawal cannot happen. We have our little test that triggers and we have an insufficient balance. So at the end, when we do display balance, well, we have the amount that we got after doing the first deposit. Okay, nice. There's another technicality that I want to point out that you can do in classes, just like you use here the self to define a variable, an attribute that is a variable, and reuse it later. For example, here we reuse it after having it defined with our constructor. You can do the same thing with a method. So for example, here I could say, like, let's say I have this insufficient balance print, but I want also at the same time to print my balance. And rather than using a print like this, what I want to do is actually reuse this display balance method that I've defined. So here you could very well do self again, display balance, and like that. So if we do that now, what will we see? We will see that your balance is 11,000 euros because of this self balance here. So note that here it's very important. The order is not important in the way that you define your method. So I'm calling here the self display balance, even though it's been defined further down in the class, but that's not a problem at all. Just remember that you always start with the constructor. This is important, however.
Okay, I think your head is probably buzzing with all this by now. I'm not going to lie to you. I think that classes is the most difficult and technical object to grasp in Python. It will take some time for you to get comfortable with it. It took all of us some time. But I hope you realize, or you're starting to realize, how this really enables us to create some real tangible examples. Anyways, you know practice is key, so this is an exercise for you.
So in this exercise, what you need to do is create a portfolio class. So basically, you want to handle some financial assets. So quite naturally, in this portfolio class, you should have a method that deals with adding assets, another one that will update the asset, another one that will remove assets, and also a method that will print whatever is your total portfolio value. So in other words, at some point, you need to be able to paste all this in your code and everything needs to work nicely and make sense. So you have all the details of the instructions here that will guide you through everything. You remember you also have a suggestion of a correction here, but I suggest you do as much as you can without looking into that. And again, this is but an example of the usage of a class. If you think of a problem that relates more to one of your needs, please do that rather than this exercise. This is just an example if you don't have any ideas.
Okay, well done for making it up to here. We are actually now finished with all the building blocks of Python. We've covered all the main topics for a solid foundation. So now in the next chapters, we can start getting serious and look into some real financial applications, modelizations, and case studies. In fact, in the next chapter, we'll look into your first Python library, the famous Pandas library, the library for handling data. So see you there and take care.